Hi, my name is Solubility and this video is to help you get a better understanding over electrolytes and the solubility rules.
Rondo's got what? That's crazy.
It's got electrolytes.
No, not those kind of electrolytes. The electrolytes we're worried about are the ones that dissolve in water and can conduct electricity. And that's the definition of an electrolyte, a substance that dissolves in water and conducts electricity, which means a non-electrolyte is a substance that cannot conduct electricity. So now that we know what electrolytes are, maybe we should get a few examples. An example of an electrolyte is salt, while an example of a non-electrolyte is sugar, because sugar cannot conduct electricity while salt can. So there are two different types of electrolytes. We have strong electrolytes and weak electrolytes. Strong electrolytes are made up of strong acids, strong bases, and soluble salts, while weak electrolytes are made up of weak acids and weak bases. Another way you can think of strong and weak electrolytes is that strong electrolytes will light up the light bulb really brightly, while weak electrolytes will only light up the light bulb a little bit. And like I previously stated, non-electrolytes will not light up the light bulb at all, because electrolytes conduct electricity. Strong electrolytes completely dissolve in water. They will always dissolve, and they will always conduct electricity. Strong electrolytes are strong acids, strong bases, and soluble salts. Just remember the three S's. Strong acids, strong bases, soluble salts. Now, the 7 strong acids that you have to know are HCl, HBr, HI, H2SO4, HNO3, HClO4, and HClO3. Now, strong bases, you only have to remember that it's the column 1 and column 2 elements with metal hydroxide. Now remember, hydroxide is OH negative. So it's LiOH, NaOH, KOH, RbOH, CSOH, and CaOH2, SrOH2, and BaOH2. So once you know the strong acids and strong bases, then you can worry about what makes a salt soluble. So here are the solubility rules. Now don't panic. They are not as bad as they seem, I promise. You just have to break them down in a way that you can understand. But first, let's just read through them so we know what they are. Column 1 and ammonium is always soluble, regardless of what it is paired with. So is NO3 minus, ClO4 minus, and acetate. They are always soluble, regardless of what you pair them with. Now, chloride, bromide, and iodide are soluble except when they are paired with silver, lead, mercury 2, or copper. Sulfate is usually soluble except when paired with calcium, strontium, barium, silver, or lead. But these first 2 points, column 1 and ammonium, nitrate, perchlorate, and acetate are always soluble. So these are the exceptions to all of the insoluble rules. Now our insoluble rules are metal hydroxide are insoluble except for strong bases, which is column 1, and column 2, which is what we talked about earlier. Also, carbonate and phosphate are insoluble except for column 1 and ammonium, because column 1 and ammonium are always soluble. And then sulfide is insoluble except for column 1 and ammonium, but with this one, we add column 2.
Here's looking at strong acids, strong bases, and soluble salts while looking at the periodic table. Strong acids are the ones that start with H+. They are HCl, HBr, HI, H2SO4, HNO3, HClO4, HClO3. Any other acid is assumed weak. Strong bases always end with OH negative. They are column 1 and 2, LiOH, NaOH, KOH, RbOH, CSOH, CaOH2, SrOH2, BaOH2. So it's soluble if it's in column 1, LiNaKRbCs, or if it's ammonium, nitrate, perchlorate, or acetate. Those are always soluble. Now, chloride, bromide, and iodide are soluble except with silver, lead, mercury, and copper, and sulfate is usually soluble except with calcium, strontium, barium, silver, and lead. Metal hydroxides are insoluble except for the strong bases as listed before. Carbonate and phosphate are usually insoluble except if it's with column 1 or ammonium, and sulfide is usually insoluble unless it's with column 1 or 2 or ammonium.
So a few examples so you can get a better grasp on solubility so that way you make an A on your test. Alright, so the products of this reaction would be BaSO4 plus KNO3. Now, what we need to do is figure out if this is aqueous or solid, or forms a solid, or if this is aqueous or forms a solid. So since we know our solubility rules so well, we can easily tell whether or not this is solid or aqueous and whether or not this is solid or aqueous. Now, according to our solubility rules, SO4 is usually soluble, except when it's mixed with calcium, strontium, barium, silver, or lead. In this case, sulfate is mixed with barium. So that makes this insoluble, which means it's a solid. Now, anything in column 1 is always soluble, regardless of what it is mixed with. So since potassium is a column 1 metal, we know that this is aqueous. So let's do a few more examples just to make sure you have it all down. Now in this one we have ammonium 2 carbonate plus 2 silver acetates. So when we mix it together, we have 2 ammonium acetate plus silver 2 carbonate. Now we need to determine whether they're aqueous or solid. Now we know that both ammonium and acetate are always soluble, so this is going to be aqueous. However, carbonate and silver are both usually insoluble, so this is a solid. Let's do one more example. We have copper sulfate plus ammonium sulfide. When we react these, we get copper sulfide plus ammonium sulfate. Okay, now sulfide is usually insoluble, and so is copper, so that makes this solid. And then ammonium is always soluble, and sulfate is also usually insoluble except with copper, strontium, barium, silver, and lead. And since it's not mixed with any of those, that makes this aqueous. And that's how you figure out solubility using chemical equations. So I hope this video helped you get a better understanding of strong and weak electrolytes and what makes up strong electrolytes, meaning strong acids, strong bases, and soluble salts. I hope it also helped you get a better understanding of the solubility rules, since they are a pretty big deal in chemistry. But if you do need more helpful hints, you can either watch the solubility song or NAGSET. Also, if you need more help on electrolytes, just follow the links below. Have a great day!